All right, so we'll go over horizontal ventilation. So for this classroom setting, I have an informal company training session going on. We're just doing a review session, more of a refresher for our fans in horizontal ventilation. So we're going to talk about horizontal ventilation. Feel free to ask me questions. We had to do a printout of the PowerPoint due to not having a projector, so we'll follow along and go and ask any questions you got. So, so there's a difference between PPA and horizontal ventilation, even though they're related. We're going to talk more about the tools we have to clear rooms and get rid of those toxic gases for our technical objectives. So our course objectives, as you see here, is understand the theory of horizontal ventilation, describe how and when to use horizontal ventilation, and we're going to explain PPV and PPA in detail, kind of go in the differences. And we have our three methods of ventilation. So first one, we had ventilation. The definition is the systemic and coordinated removal of smoke, heat, fire, and toxic gases from a structural in a timely and professional manner. So like Laura, why do we do ventilation? What's our main purpose to vent the property or the house, the structure?
Get rid of heat.
Prevent mushrooming.
Yeah, prevent
Clear
mushrooming,
access.
clear the building. Our technical objectives are
All clear, which is rescue.
Yep.
Fire control.
fire control, right, and then
property
property conservation.
conservation, one stop.
Yeah, exactly. So in order for us to efficiently and safely get those objectives, is we gotta clear the property. So we gotta get all that smoke out of there. It's gonna increase survivability of any victim to the site. It's gonna keep us safe, give us visibility, especially get to the seat of the fire. You know what I mean? Like we wanna figure out where it's coming from. So clearing that house is gonna get us the most efficient way to put the fire out. So we kind of talked about already with our vent priorities. So it provides a safer work environment and supports suppression activities. So like we all discussed, get the smoke out. It's going to let us locate the fire. It's going to increase survivability of the victims and also get us to them. And also in the end, it decreases property damage, right? So we clear the smoke out. We were pretty good at putting out the fire, but our biggest thing is water and residual smoke. So we get that smoke out. It's going to save a lot more property. So like ventilation priority for today versus 20 years ago is cellulose versus synthetics, right? So everything now is synthetics, dude. Plastics, nothing is just plain wood anymore. Class A fuels, everything burns hotter. So like as you see on the PowerPoint there, ordinary combustibles are 5,000 BTUs versus nowadays it's 15,000 BTUs. So the difference with that is flashover 20 years ago took about 14 minutes. Now it's about 4 minutes. So that's why getting that smoke out gets the heat and the smoke out of the structure. That way we're reducing the flashover condition. So we want to remove all the energy in that lethal environment as quick as we can. So again, our vent priority and why we do ventilation or horizontal ventilation is to assist in our tactical objectives. So it keeps us efficient and it keeps us safe for everybody on the fire ground. This is kind of a fun fact. So, we're very cautious with propane. We would never, an active propane leak, like, we're not going inside, we're super cautious. And this is a good comparison with what the gases produce in normal house fires versus propane. You see here the thermal range and ignition temperatures are nearly the same. But we don't keep being that cautious with house fires. We go get it, take care of business. But propane, we're super cautious, but honestly, we're dealing with the same gases. So our three vent methods is going to be horizontal, vertical, and mechanically assisted. So like, what would be mechanically assisted? Anyone? A fan, yeah, fan. There's one more too. Oh, there's actually two more. Yeah, hydraulic ventilation. Yep. So you have fan, hydraulic, and then like systems, like HVACs, and then sucking all the way around. So those are three. Our main ones that we usually do is hydraulic and fans. So going to the page here, we have this vertical ventilation. It's simple as that. We cut a hole in the roof, and the products of combustion come out. So it's getting hot, smoke is mushrooming. We're gonna cut a hole. Like we're inside, hey, we can't see anything. It's getting hot. We need vertical ventilation right now, and that's why we always have ladder on the roof. Give us that, that hole that over the fire or close to the fire if we can. What's our rule of thumb for vent holes? I think it's 10% of the roof surface is their goal. If they want more holes, we don't make it bigger, they make an additional hole next to it. big thing to consider is, when we're doing vertical ventilation is the building construction type, right? We can't do vertical ventilation on type 2 structures with those roofs, with metal roofs. We can use their natural, like vent openings, skylights, but we can't cut holes on type 2 buildings. So building construction is a big, you gotta think about that before we ask for vertical ventilation. And then once we decide to cut, there's no going back. There's a hole in the structure, we gotta make sure we put it out quick. Because we're just feeding the fire with more oxygen. So once that hole's cut, we gotta put it out. So true horizontal ventilation is vent limited in effectiveness. So to be most effective, the fire would ideally be on the leeward side of a structure. This turn limits the fire attack to the windward side. So that's just more keeping wind and location of fire in account, okay? Again, with horizontal with our fan or horizontal vent considerations, it's wind direction, velocity, our temperature differential, and then make sure we have a good exit route for the swim exhaust, right? So, and also size of the exhaust is super important. So this is where PPA and also just and PPV kind of come into account, or they're similar, is we need an exhaust. So we need an adequate exhaust. So we can't just open up one little window on the opposite end. We want to follow that flow path. We want to make sure that that size or the vent opening, the exhaust, is going to be sufficient enough to get all that smoke out, okay? So hydraulic, yeah. So this is kind of a tool we add to it. So we have fans going, we found a window, we're clearing that smoke, we're not getting enough pressure, right? We still have that lazy smoke, still can't see. It is absolutely okay to be aggressive and open up another window and use that semi-fog out the window and push that smoke out. We do it all the time. It's super effective. In the academy, I was kind of like, this is not, let's see how this works. But every time that we've done it, man, it's quick, It's easy to control too. So, our fans. So, I think Surprise Fire did a good job with our fans. Like back 10, 15 years ago, just our ladder had fans. Right now, there's one in every truck. I mean, they're deployed almost as quickly as our attack lines now. So we're doing a really good job of staying in front of that and using our fans. So we have negative pressure and positive pressure, right? So negative pressure, to put it simply, is the fans inside, right? So maybe we're kind of an overall, got some residual smoke, we want out. You place the fan inside the structure at an exhaust or opening, and we're doing the negative pressure out the window, okay? And then if you switch over here, how PPV works, this kind of explains why we need exhaust and the flow path. So the intake side is where we're coming in, and when the fans get set up and where we're coming in the structure, that's going to be the intake. And we want to make sure we have an adequate exhaust, okay? So once that fan's set up at the intake and we're going to the exhaust, A to B is the flow path right there. We're creating that flow path, okay? So the challenges with mechanical ventilation, the biggest ones on these I want to point out is backdraft situations, right? It's with backdraft scenarios, it needs oxygen. So we have a hot fire, it just needs oxygen. Okay, so we blow a fan out there, we're gonna get a backdraft or a smoke explosion. Okay, we need to accurate size up the conditions. Also, too, don't just throw out a fan. Attic fire, sometimes if we don't have good exhaust or good knockdown on that fire, we're going to spread it. So we got to make sure we know where the fire's at, where it's located before we set the fan up. And again, the biggest thing too is not an effective exhaust. It's too small. Okay. So here's our vent fan configurations. There's really 4: single fan, inline, combination, and V point. We usually use single fan. That's going to be what we use usually, but there's ways to kind of add to it. So the inline series, and you see these fans, these are our fans we have right now, okay? If we're not getting good pressure or good smoke movement from one fan, we'll get to add more, okay? So do you guys know like the cone, how far back we should be when we set up a fan?
6 to 8 feet?
Yeah, there you go. So I think 10 to 12 is volume 2. We kind of dumped down to 6 to 8 feet because of our properties, but it worked out great. Inline, okay? So tandem. If we need to add the fan, we go tandem, okay? If we're using our inline fans, which will be tandem, okay? 20 to 30 degree angle. So a big way to tell you're getting good conversion or it's an adequate cone is, you want to leave a little bit of a plane between the top of the door jamb and where the fan's coming in. you can watch that smoke invert pretty much. Now you're seeing it go into the house. Instead of coming out, you're watching it suck back into the house. That's when you know, okay, we're getting, you know, the fan's placed correctly, we have a nice flow path going now, and we're good to go inside, okay? Parallel fans are kind of used for big openings, so if we do side by side, it's great for a garage, okay? And then our V-point fan, so we could do this if we wanted to. They've actually done studies now that show maybe is having two fans side by side at 45 degrees is more effective. It's still kind of in the training portion of it, or we're trying to figure it out, but that's another option we can do too. So that really covers our horizontal ventilation. And any questions? No, all right, cool.